Hello friends, this is Professor Amit Solanki from S&D College of Engineering and Research Center, Yola. Now today we will continue our topic which is started in last lecture, that is the chopper fed DC motor drive. In previous class we have already discussed the chopper fed DC motor drive, what are their advantages. Okay. And what are their specifications. Now in this lecture we will discuss about the chopper controlled separately excited DC motor drive. So in that lecture we will see that how to separately excited DC motor is connected and what we are getting the performance to be connected of the chopper. So let us first understanding the motoring control. In motoring control, a thyristor chopper control of separately excited DC motor is shown in figure. As you can see in this figure, we have connected the separately excited DC motor with chopper connected. As we already discussed, in that circuit diagram we can see here, thyristor T1 is operated periodically with a periodic time T and remains for duration of T on. Present day choppers operate at a frequency which is high enough to ensure continuous conduction. In that circuit diagram you can see here, the chopper operates at a high frequency which is high enough to ensure the continuous conduction. Waveform of motor terminal voltage VA and armature current IA for continuous conduction shown in figure. So during the on period of the transistor, that is the time period from the 0 to T on, the motor terminal voltage is capital V, right? So in that you can see here, this is the circuit diagram. In that circuit diagram you can see here, this is the thyristor T1 voltage, this is the inductance LA, this is the freewheeling diode, and this is the armature with field winding connected. In that you can see here, this is the quadrant EA to IA. In that it will be operate in the first quadrant. Okay. So according to circuit diagram, we have draw here the waveform for chopper controlled separately excited DC motor. In that chopper controlled separately excited DC motor drive, you can see here the gate pulse. This is the gate current. We have provided the gate pulse to the chopper. This is the IA armature current, EA armature voltage, or we can say that output current and output voltage. When the gate pulse provided from this point to this point, that means it is on time. When chopper is on or switch is on, at that time the current will increases from their minimum value to maximum value. Okay. And after that, when chopper is off, at that time what will happen? Current is goes down from maximum value to minimum value. Okay. And after that, we can see here what will changes with respect to voltage. This is the T on time and T off time. Okay. So in that time, the T on time, the T off time, when switch is on, then what will happen? The voltage is produced with some magnitude. When T is off, when thyristor is off, there is no output current, and at the same time the current will be decreases from maximum point to minimum point. So this is the all about the concept for the chopper control separately excited DC motor drive. That we can see here the overall waveform for the chopper control separately excited DC motor drive. And if we are discussing about their description, So in this interval, armature current increases from IA1 to IA2 as we already see in the waveform. And since motor is connected to the source during this interval, and it is called the duty interval, right? At the time t is equals to t on, capital T1 is turn off, that means thyristor is turned off. Motor current free will through diode D of F, and the motor terminal voltage is 0 during the turn off time. During this interval, that means T on with respect to capital T. The motor operation during this interval known as freewheeling interval. Okay. So during that time interval, the operation of motor is called as a freewheeling interval. And it is described by the RAIA plus LA, D of I upon dt plus E is equals to 0. And T on time is T. At that time, according to this equation, the motor current decreases from IA2 to IA1 during this interval, and the ratio of duty interval or duty ratio of T1 to chopper period capital T is called the duty ratio or duty cycle. Okay, as we denoted by del, duty ratio or duty cycle. So according to this statement, we can write here the equation: duty cycle or duty interval is equals to duty interval upon T is equals to T on small t on upon capital T. So we can write here the equations of output voltage. VA is equals to 1 upon T integration of 0 to T on V of dt is equals to del V. Are also applicable here. I of A is equals to del V minus E upon RA. Okay. So this will be all about the concept for the armature current, and from putting this equation, we are finding out the speed of the omega m is equals to del of V upon K minus R of A upon K square into T. So this is also the equations. From that we can find out the value of speed. So now you can see here in this figure the torque speed characteristic of chopper fed separately excited DC motor is shown in this figure. This is the, in that figure you can see here. In that we are discussing about only motoring action. In that the del is increases. Okay, this is the del, that means duty ratio. This arrow shows that the del or duty cycle is increases. This is the graph between speed and torque. Okay. Now we are discussing about the chopper control of DC series motor drive. The chopper control of DC series motor drive. In that motor drives, we have observed the working principle and diagram of the chopper controlled DC motor drive. Okay. In that you can see here the motoring control of series motor. In that diagram you can see here we are using the series motor. Okay. Series motor, that means armature and field winding are connected to the series form. The main drawback of the analysis of chopper control series motor is arises due to the non-linear relationship between induced voltage E and armature current IA because of the saturation in the magnetization characteristic. So this is the one of the big disadvantages or drawback for series motor. At a given motor speed, the instantaneous back EMF E change between E1 and E2 as IA change between IA into IA. In this circuit diagram, you can see here we have connected the chopper, and that we are using here the thyristor and also freewheeling diode. Here is resistance connected, that is the RA and RF, armature resistance and field winding. Now in that you can see here the torque, speed torque characteristic and del E of D, that is equation. In that you can see here what about the relation between speed and torque. So according to that we can find out the equations for the torque. as you've seen in this diagram. Now we can see the regenerative braking of DC series motor. As we earlier discussed already braking method. For in that we can see the chopper controlled DC series motor. In that we have seen the what are the regenerative braking. With chopper control, regenerative braking of series motor can also be obtained. So during this regenerative braking, series motor function as a self-excited series generator, right? So for self-excitation, current flowing through the winding as field winding should assist residual magnetism. This is all about the concept of this regenerative braking of DC motor. So therefore, when changing from motoring to braking connection, when armature current reverses, field current should flow in the same direction. So this is achieved by reversing the field with respect to armature when changing from motoring to braking operation. So these are the all about the concepts of for today's lecture, which is based on the chopper field separately excited and series motor. Thank you so much for watching this video.